And what Anupam's going to step us through is explaining how this syntax works underneath. And once you understand that, you've basically understood the core of LangChain.
So that is like, that has the prompt. The prompt is then given to the model, and the model, then the output string parser kind of give you the output. So let's look through the chain step by step what it is doing. So we have given the prompt. And is like the prompt takes like, tell me something random about the topic. We would invoke the topic. So if I invoke Melbourne, so it gives me, the model give me something, random topic about Melbourne. And this is the way like we could pass some prompt, and it will do these things. And to see what is like the prompt is kind of, so we want to print the what is the prompt is doing. So that is like the message. That's the human message is, tell me something random about Melbourne. And similarly, like you could also see what is inbuilt within the model.invoke by using the cell in the cell 7. So that kind of have yeah, right. Like, so it has the content of what is given, and then what would be the output and all other details. So the main thing we have to really understand is this operator that is like the pipe operator. So what is a pipe operator in Python? This is like, if you just give me 15 pipe 2, it would give you 15. It is kind of like the byte-wise addition. So you write 15 in binaries, like that is like some 0, 1, 0 combination, and you write 2 in that, and you add them up. What would be the answer? That is the pipe operator.
Yeah, so if anyone's done low-level programming or C code, you might have come across that before. In languages like Python, we probably don't have a huge lot of use for that operator. But we can override it with our own definition.
So now what LangChain, because they wanted to use this for something different. So hence like they're defining hence they're defining a class for the pipe operator, right? Like so if you see that this class we call the C runnable, and that's like an abstract class. And if we read the class, there is a constructor that is kind of set to none, and then there's abstract method for the class that is process and invoke, that you already see that we have already used it when we were kind of using that. And there is another class that is C runnable sequence. So you can see the class has kind of like, so this class C runnable and has 2 constructor, right?
Well, we're overriding 2 sort of special Python methods.
Okay.
So we've got init, which is common for any kind of Python class you define. And then we've got or, which is sort of the built-in Python pipe operator, which we're going to override for our own purposes.
Right. And so and this pipe operator return the C runnable sequence class that is kind of defined later, like this, that 2 parameters other than self, so it will kind of naturally what you think it would do, but it will then also there is a process, and I think it will rewrite the method process that is already defined in the class C forming. The recursion is happening like at the stage here, right? Definition invoke, where if you see like is kind of recursion is happening here.
The simplest case of you just have one thing pipe to another. Once you can do more than that, but it starts getting recursive. So for the simplest case, we just have one thing piped to the other. You've got your data come in here. So in our case, we were calling it with Melbourne.
Correct. Yep. Yeah, exactly. Yeah. Now, if we go through this one, like maybe like if we go through this one, you see the invoke prompt invoke topic. Yeah, right. The data goes through Melbourne and then it get processed.
And the process is actually up to the user to define. So we could define our own thing that say adds 2 to it or multiplies it by 10, or LangChain provides some built-in ones, like where we had the model that's say to pass it to LLM. But once you sort of understand the syntax, then it sort of gives the power to build your own that can do whatever. And like this is the core of LangChain.
So maybe like the best way is like understand this by example, right? So so actually let's define. So we have two classes, C runnable and C runnable sequence. So let's have an instance of those class, and then we define method. So like let's we define this class like add 10, and that takes in argument the C runnable. Yeah, and then class multiply by 2 and class convert to string. Yeah, so now like okay, so now as we start with those instance of the class A, B, and C, now we are going to form our chain. So first, like, so we have defined the pipe operator. Now we have two class instance A and B. Now we define kind of the A pipe B. So, and you were asking me a question about it, like what is the class of A pipe B? Right. So can anyone guess like what would be the class? So we know what is the class of A. We know what is the class of B. So what do you think the class of A pipe B? Yeah, you can go through and check like okay. So how can we check this? Like we have to. So this is like this is the pipe operator, right? So yeah, any guess? Right, you online want to think about it?
Can you hear me? Yeah. So essentially, sorry, are we just calling a recursive function essentially? Is that like is that what the pipe is doing?
Maybe just use one mic. If you speak, it will be things in you. So
in a way, say thing pipe to another, not yet. Recursive.
But like recursive in the sense of like we're doing the recursion on a different function.
Yeah, sort of
invoke
methods.
Yeah.
So like in the case of 2, we get the C runnable sequence of a C runnable sequence.
Yeah.
And so when we finally call the invoke in that, we'll call invoke on the left-hand side, which is a C runnable sequence, expand that, and inside that, we'll finally get our first thing and then pipe it to the base. So we construct this big tree of C runnable sequences inside of each other.
So you see like the invoke function. So it is a method and it is calling the invoke function as well, right? So yeah, you see like if it is not none, then it is again calling this. So there is the recursion.
In the case of 2, next dot invoke just sort of calls the next thing in the chain. But once we got a longer chain, this
I think it could be used. Can you use screen for
Bigger. Oh,
okay. I want to
you can,
verify.
go ahead.
yeah,
And yeah,
we
feel
might
free
just repeat what you
So
say.
it's A or B, right? And then you return serial sequence A or B. Then I think the first one is A, the second one is B, the election.
Oh,
And then you revoke it.
so the A, like the one, like we go to this example, then we can explain to this example, then the.
Yeah, so we've just got some examples in person. Are we just doing the chain of A pipe B
Yes,
or
this
just this one? Yeah, so let's start off simple. So we've got A is add 10, which itself is extends C runnable. And B is multiplied by 2, which is a C runnable. So this pipe operator is going to be called on A. So the pipe's not defined on add 10, but it's then C runnable. So we go up here and it's going to call this. So yes, in this case, self is going to be A, which itself is a C runnable. And other is going to be B, which itself is a C runnable. And it's going to sort of combine them together into a C runnable sequence, which is itself a C runnable.
So may I ask, like A or B is runnable, like a single C runnable for user?
Yeah, so when we pipe A and B together, we get a runnable, but it doesn't actually do anything until we come and invoke it with some data.
Like we combine into a single C runnable.
Yes, exactly,
Yeah.
exactly. And like that is what makes the whole thing
Okay.
work. Because now suddenly, rather than invoking things on sort of a single processing, we can pipe things together to create one big object, and then we just invoke that. And inside, we don't have to think about it, but inside it's going to pipe along the chain.
Yeah.
So yeah, I think like a lot of people would be happy just to sort of copy examples, but I think Anupam, when he saw that, he really wanted to understand what was going on inside. And I think once you understand what's going inside, it gives you a sort of a lot more power and everything just sort of makes more sense.
Yeah, that makes sense. Yeah.
Yeah. So maybe let's, for the first one, say all this is doing is just creating like a new chain, a new thing that we can run. So I'll ignore the third thing because when we finally invoke it, we've got a chain, we're calling the invoke. And because that thing is a C runnable sequence, we can invoke it and it will, the second thing, which itself can just sort of pass it along. So yeah, I think in the case of three things, like this first itself will probably itself be a sequence. And yeah, that's the recursion that Ravi mentioned. Cool. Any questions about that?
I have a small question. Like, what if we don't have second C runnable? Like, we just have A only. What will happen if you invoke it?
Okay, so the question is, what happens if we don't have a second C runnable?
Can we see and test and see?
Yeah, let's
do it.
see and test. Let's do it.
Yeah, that's way too long.
Okay.
We get a value error.
I just want to insert a cell so we can.
Oh, you want to add a cell? I think that you can do it from there, no? There's a plus symbol. Yeah, like from there.
Cool. I'm just used to using the shortcuts, which for some reason isn't working.
Where we can keep.
Okay, so equals. Let's just do that 10. Wait. So this is like the simplest possible case. So if I add 10, we define process, which just adds 10 to the data. It's pretty boring in this case though, because when we're calling invoke, yeah, I think how they had all this stuff about like is not none. So in this case, there is nothing else in the chain, so we just go ahead and return the process data. So yeah, you can call it just on a single C runnable, but I guess it's a bit more interesting once we start to have change of things.
So your question was that just by itself, or
I just focus on the C runnable
class?
This is the next one.
Yeah, we probably should have started with that before we went on to chains. Cool. Any questions about that from online? Yeah, I think we're pretty much all good. I think you do. Did you do another example?
No. So I was just thinking, like I was saying, so what class like you define there, and then I think LangChain has 3 main classes. That's like runnable pass-through, runnable lambda, and runnable parallel. So it's kind of defined in a similar way. And then like what runnable pass-through do is just don't do anything. For example, in this context, like if I'm asking a question in a LangChain, I could use like a like I can make a chain like with runnable pass-through like this. And then it would not, and if I just invoke it hello, it will just give me hello. So runnable lambda is like where you can define a function and then you can apply the function on your some of the queries and whatever you want to do with the data, what you're passing to. And yeah, and runnable parallel is something that you can parallelly run, or certain things that you're like, it's kind of like, say you have a data set and you want to apply like a lambda function to every of the rows altogether. So that kind of concept.
Yeah, and so we don't have time to go through all the others today, but like with those kinds of building blocks, you can construct anything. So I think we were having a conversation with Zach about sort of LangChain versus Llama Index. And I haven't used Llama Index, sorry. Yeah, I haven't used Llama Index myself, but it seems like Llama Index's focus on sort of supporting RAG. It may have had more things it can do since then, I'm not sure, but like that from the name, that seems to be what it's about. Whereas LangChain, RAG's one of the things it can do, but with these pipes, you can sort of construct pretty much anything. And so, like,
I guess it's a good building block for agents as well, I guess.
Yeah,
there
exactly.
Right.
Yeah, so like if people are interested, and I think there's a set of notebooks called RAG from Scratch, which we could optionally do a session on, which basically uses these concepts to much more elegantly than what I did in the first session, where I was doing everything sort of manually, construct a chain that can do RAG system.
You like even if you don't even know like those kind of what is the pipe operator, the class or anything, you could do any of those things without even understanding what is really doing this. But like, yeah, once in or like you have, if you just understand that bit, we have, say we're making our system and everything, so it would be helpful at that time.
Yeah. I was going to ask as well, does LangChain have like a built-in like indexing
Does it have a built-in indexing?
Like what I can see, like Llama index, like the main use is just index your documents, and then go from there. Like if you were using LangChain, would you still like, does LangChain have their own inbuilt like indexing, or you would just use as like one of your C runnables, you would just use like Llama index to index it?
Yeah, so in case that didn't pick up in the recording, the question was, does LangChain have its own way to do RAG indexing? Or would you just maybe cool out the index from LangChain? So LangChain does have some community extensions. So I think in the first session I did, I actually borrowed, I think, the Chroma DB community extension, which is just for an in-memory vector data stuff. Could you cool Llama index from LangChain? I'm not sure. Like technically, you probably could. I'm not sure if people would do that in practice though, or just use the built-in LangChain community extensions.
Yeah, I think that's a good question.
Cool. Okay. Thanks, everyone. That ends the meeting, and I'll upload this to YouTube afterwards.
And later you can post your questions and all, so we can have a chat about this object-oriented kind of stuff if you want to have a discussion. So I think it's always good to know.